The Partition QoS policy. The Partition QoS. The Partition QoS is used as additional criteria to determine whether or not data writers should be connected to data readers of the same topic. In essence, partitions are a set of extra labels that are defined by strings, and when used, data readers and data writers are said to be in those partitions. Only data writers and data readers of matched partitions will be connected to each other. Partition QoS is actually set for the DDS publisher and DDS subscriber entities. These are the parents of data readers and data writers. So when you set a partition QoS for a DDS publisher, it's actually applying to all the data writers it's created. And similarly, for a subscriber, it applies to all of its data readers. A data reader or a data writer can be in multiple partitions simultaneously. You can set more than one partition in the partition QoS, and a data reader or data writer will be in all of those partitions. Using partitions allows you to dynamically change which data readers talk to which data writers, because you can change the partition QoS dynamically. So, partition strings, partition labels, can be either concrete, these are also called logical partition literals, or they could be matching filters, matching filter expressions, also known as regular expressions. Now, concrete or logical partitions that are defined by a string of any characters except for some special characters, and those are the ones listed. You can use those special characters only if you escape them with another special character. A matching filter or regular expression, well, this is an expression that follows the POSIX FN match syntax, so you can look that up on the network and to understand what that syntax is. But they're used to match concrete partitions. So you could use an expression, you can think of it as a wildcard expression, and you could have wildcards such as A star, so that matches any concrete partition that begins with the letter A, or you could have a range, bracket A dash C, close bracket, star, will match any concrete partition that begins with a lowercase a, lowercase b, or lowercase c. The Partition QosPolicy is configured by a string sequence called name. The name string sequence is basically a list of strings that define either a concrete partition or a matching filter. So each string can either be a partition or a filter. The Partition QosPolicy, again, is set for a DDS publisher or subscriber object, and the filter is using the POSIX FN match expression syntax. Now, when you use a partition QoS, the connection of a data writer to a data reader of the same topic is only allowed if there's at least one concrete partition that's being shared or has been matched with a filter between the two. You can change the partition QoS dynamically. You do this by using set QoS on the DDS publisher or subscriber object. And this will cause discovery packets to be sent out on the network. These are new discovery packets for the data writer or data reader that tells everyone that the partition for that data writer or data reader has changed. So this is a changeable QoS, but we are not really using this as a request versus offered. You don't think of it as request versus offered. However, it is being used for the final matching of a data writer to a data reader. Now, the Partition QosPolicy can be changed dynamically, and it's actually relatively low overhead to do so, except for the discovery packets on the wire, which are not that big. But it is what we call a lightweight way of controlling which data writers talk to data readers, and you could do this dynamically. So at some point in time, you could have a data writer connected to a data reader, and then by changing the partition, they'll be disconnected, and by changing the partition again, they'll be connected again. Partition matching. First, let's talk about the default setting of the Partition QoS for publisher and subscribers. By default, the Partition QoS is an empty list, so there are no partitions that have been set for the Partition QoS. However, by default, this means that the data writer and data readers created for those publishers and subscriber objects are in the empty partition. and the empty partition is defined by the empty string. An empty partition is a concrete partition and will be used for matching if needed. Now, if you do set a partition QoS, so you set concrete values or matching filters in the partition QoS, you are changing the partitions of the data readers and data writers. That is, they are no longer in the empty partition, unless you set the empty string as one of the partitions in the partition QoS. So you can actually have the data readers and data writers be still in the quote-unquote empty partition by setting an empty string in the partition list. Now, as discussed, a data writer will be connected to a data reader only if the partition QoSs of their publisher subscriber object matches. Now, what does it mean for partition QoSs to match each other? Well, there's two matching criteria. One is that the data writer and data reader share at least one concrete partition. So the publisher QoS, partition QoS, has a concrete partition that is exactly the same string that's been set for the publisher's partition QoS also is in the subscriber QoS of the data reader. So that's a concrete partition that's going to be found both for the data writer and data reader. That's one way to match. Another way to match is that a matching filter matches a concrete partition. So if the data writer has a matching filter, it matches a concrete partition for the data reader. Or the opposite, the data reader has a matching filter that matches a concrete partition for the data writer. Note, however, matching filters are not matching with each other. Matching filters do not match other matching filters. What does this mean? Well, we'll see that next. So, let's take this example. We have a data writer that has partitions apple and orange, a data writer that has partitions grape and P star. P star is a matching filter. And the third data writer has G star as its partition. So it only has a matching filter as its partition. Now, the data reader has apple as its partition. There's another data reader 2, has peach and O star. O star is a matching filter. And finally, data writer 3, who has two matching filters, G star and P star. Okay, given that all these data readers and data writers have those partitions set, and assuming that these are all on the same topic, who will talk to each other? Well, data writer 1 will talk to data reader 1 because apple matches apple. It will also talk to data reader 2 because data writer's orange will match data reader 2's O star matching filter. Anything that begins with the letter O, capital O. Now, data writer 2 will match data reader 2 because data writer 2's P star matching filter will match data writer 2's peach concrete partition. It will also match data writer 3 since data writer 2's grape will match the G star of data writer 3 or data reader 3. Note, data reader 3 has no match. So you might think, well, data writer 3 has G star and data reader 3 has G star, so they should talk to each other. But no. Again, filter expressions used for matching, these regular expressions used for matching, are not going to be matching each other. We don't compare matching filters to matching filters. We only can compare matching filters to concrete partitions. Let's look at a practical example. And here we have a ship, and each box represents perhaps a cabin or an area of the ship. You know, we have different sides of the ship, aft being the back, forward, port, the left-hand side, starboard, the right-hand side. Maybe we have different rooms. We have engine rooms, we have dining rooms, we have the bridge, a control room, and we have a pool, okay? So let's say we're building an intercom system, okay? We're building an intercom system. So every compartment has basically a telephone in which they can either receive or send communications or talk. They can talk to each other. So what we can do to use DDS is each intercom subscribes to the intercom topic, okay? But we'll use partition, okay? And we'll set its location, its section, and its deck, okay? So the location could be port, starboard, aft, forward. The section could be cabins, engine, dining, bridge, pool, and the deck, it could be, deck 1, deck 2, deck 3, deck 4, deck 5. So here's an example, that particular cabin there may subscribe, its application may set a subscriber partition to port because it's on the port side of the ship. It's a cabin. Okay, so it's the cabin section, or it's a type of room that it is, and promenade deck. It's on the promenade deck. Whereas here we have the engine room. Okay, engine room is in the aft side side of the ship. It's the engine room, and maybe it's in the most lowest portion of the ships called steerage. So as a publisher, if I want to talk to somebody. Okay, if I want to talk to a room, like I'm the captain on the bridge and I want to talk to somebody, maybe I want to talk to everybody on the port side of the ship. If I want to talk to everybody on the port side of the ship, I set my partition to port. And then all subscribers, all applications in which they have a data reader with a subscriber that also has port, well, I'm now connected to them as a publisher. I can change. Now I don't want to talk to the port side of the ship. I want to talk just to the engine room. I could change my partition to the engine room. And now I'll talk to the engine room. Maybe I want to talk to the forward section and aft section of the ship. I don't care about the people in the middle. I want to talk to people in the front and people in the back. I could have multiple partitions, and then I'll match all the data readers that are in the forward side of the ship and the aft side of the ship. And then if I want to talk to everyone, I could use a wildcard. Okay, star. I'll talk to everyone. I don't care where you are. I need to talk to you. This is a ship-wide broadcast, so I could use a wildcard pattern. So here's a kind of a practical example in which you want to divide up, even though you have one topic, it's the intercom communication topic. You want to divide up who you want to dynamically control. Who you want to talk to at the moment you're talking. And this is something that's dynamic. Sometimes you want to talk to these guys, sometimes you want to talk to those guys, and you could dynamically change your partitions, and DDS will map that for you and figure out who you're actually going to talk to. So other practical use cases, okay? For example, we have customers who are using partitions to define operational versus training mode. So you may have applications that consoles, that you're going to use, and they can either be in operational mode where they're getting real data, or they're in training mode in which they're getting training data or simulated data. And you don't want your operational system to be getting information from the training applications. I mean, you might be doing training in an actual ship or an actual room, and you don't have a special training lab or training room. You're actually going to do your training there. So your actual room maybe has multiple consoles, and some of those consoles are in control of the actual system operationally, and the other consoles are going to be used just for training. At least at that time, it's going to be used for training. So you use partitions to divide operational versus training. You may have different versions of the same data stream. Okay, you may have live data streams, you may have simulated data streams, you may have recorded data streams. So it's the same topic, okay, the same set of topics, except it's simulated data or recorded data or live data. So you may want to select between those, okay. And again, in our example that we used before, partitions can also be used to identify different geographical positions, and then you could select, who or which sensor you're actually trying to talk to or get information from. In summary, the Partition QoS policy is a really powerful way to dynamically control which data writers talk to which data readers, again, for the same topic. Now, partitions are defined by strings and assigned to publishers and subscribers, and a publisher and subscriber, and thus their data writers and data readers can be, quote unquote, be in multiple partitions at the same time. A data writer and data reader can only connect if their publisher and subscribers share at least one partition, or they have a match in which a filter on one side matches a concrete partition on the other side. And then changes in the partition QoS policy. You could change filters, you could change the concrete values that are used in the partition QoS policy. Those changes are propagated through a DDS discovery. So when you do a set QoS to change a partition QoS value, that change will be sent to all the other applications on the network through a discovery message.